Hello, welcome to all. Today we will discuss about the Satec energy meter integration at the new AG2 sites. Here in the picture you are seeing this is a LT panel. This kind of LT panel has been installed at all new AG2 sites, whether it is a standalone new AG2 constructed like a shelter or greenfield site, or those AG2 which has been installed inside the MCN, ARCOM MCN. But overall LT panel which we are seeing in this picture is same at all new AG2 sites. This LT panel has been supplied by the L&T company, and this LT panel is support for the 3 power source. Like here we can see this is a one EB, this is the DG1, and this third one is a DG2. Now normally this new AG2 sites which is supplied with the grid power and the single DG, but there are a few AG2s where double DG also has been installed. So we will discuss both the scenario, that how this Satec meter which is installed here, which you can see this is a Satec meter, which is an energy meter, ACM meter also we can call it. This energy meter's reading should be visible in the Zabbix, and that is what the main activity which we need to complete by seeing this tutorial. And after that, if you do all this instruction physically at the site, your all data will be visible in the Zabbix. So that's what we are here to learn today. Now in this picture, if you see, this 3 meters has been installed on the all 3 section of EB, DG1 and DG2. Now there are 3 this PCBs has been given separately, which is installed inside this cabinet. So there are 3 RS485 PCB has been given. Okay, so first of all we need to understand that only one PCB is required to connect EB, DG1 and DG controller. We don't require another 2 PCB if you have only single DG. So even if it is given here, it will be considered as a spare, and you should not connect it in the system. So first we will understand that how single DG and single SMPS can be connected and can be made visible in the Zabbix portal. So doubt has to be very clear that there are 3 PCBs, but only single PCB is being used to connect your EB power source, DG1 energy meter, EB energy meter and DG1 GCU. These 3 will be connected with this PCB, and this PCB is directly going to connect to the SMPS. So it's a very simple connection diagram that we need to understand. In this picture you are seeing this is a PCB layout. Okay, so this left and right, which is output terminal, like J1 and J4 are output terminal, and J2 and J3 are an input terminal. So we need to only use one input and one output. Okay, so like if my all wiring like EB, DG and GCU will be connected positive together here and negative to here, so this is the input is completed, and from J1 I have to take output. This output one is positive and one is negative will go to the SMPS. Then you should not use this J3 and J4. If you are using J3 as an input, then you have to use J4 as an output. So either this J3 is input and J4 output, or J2 input and J1 is output. I mean output is the cable which is going towards the SMPS, and I mean input, that means cable from LT panel meter and GCU which is coming here. This is called input. So this J1 and J2 are input output, J3 and J4 are input output. Either you should use J1 or J2 or J3 and J4. You should not use both together. So here in this drawing you can see, in this picture you can see that this is the input which has been coming from EB meter, DG1 and DG1 GCU. This all 3 positive and 3 negative is connected here, and from here the 1 positive and 1 negative RS485 which is going to the SMPS terminal. So if this is the way you will connect this PCB, then all your data will come to here, like DG kWh, EB kWh, and from GCU DG run hour and DG fuel. This all will go from this PCB to here, and it will flow to SMPS controller, and from here it will go to the Zabbix. So this is what the main important part of this entire tutorial, that this PCB should not connected in a different way, otherwise your RS485 connection will be not giving you any data in the your Zabbix. So first part is the correct connection, and second part is the correct settings. Now here this layout will just give you the pictorial layout that how this SMPS and Satec energy meter is being connected. So if you see, this is a Satec meter which is installed on your LT panel. From there, this is a RS485. From there it will go to this PCB. This PCB, as I told you, this is a input and this is a output. So this meter, like there are 3 meters, I have shown only one, but you have a DG, there are 3 meters, DG1, DG2 and EB1. So DG1 and EB1 will be connected directly here together, and GCU also will be connected here. So there are a 3 positive, 3 negative, and this output will be going to the SMPS. Okay. So if you see the SMPS here, you see this is a 33 and 34 is a terminal. So this terminal, this output connection from this LT panel, it will go here, and from here it is already interconnected with the SMPS controller. So this is the sites where RTU is not connected. All the data is going through the SMPS node. There you have to follow this. Wherever RTU is connected, your Satec meter and the DG controller will directly go to the RTU. It will not go to any SMPS. So normally, as on date, what we are having a problem is wherever non-RTU site, where SMPS is the main controller for all the parameters, there this connection is not proper, and that is why we are not getting data in the Zabbix. So irrespective of any site, whether it is a RTU site or SMPS controller node site, this connection of PCB is common for both the scenarios. So we need to correct this connection, because I have found that few PCBs are wrongly connected. People didn't know which is the input and which is output, and that is why this problem is coming. So we have to reconnect this PCB. First of all, we have to see that whether connection is right or wrong. If this connection is wrong, we have to rectify it, and after that, in the Satec meter as well as in the SMPS controller, we need to do the correct settings and configuration. Once we do these two things, our integration will be successful. This is a Satec meter back view. Here if you see, this is a RS485 terminal has been given. So this meter, you have to connect one positive, one negative, and the earthing here, and this two cable, mainly positive and negative, will go to the another meter, and from there GCU, and all these positive, 3 negative will be directly connected to the PCB which I show here. This here it will connected here, and from there here it will go to directly to this SMPS 3334. So connection is very simple. Okay, it is just a loop connection. Now I am just giving you this two different scenario where one PCB is rightly connected. Like here you see there are 3 cables are coming, 3 blue wires are coming, okay, and 3 red is coming. So 3 negative, 3 positive, one from EB meter, DG meter and DG GCU. All these 3 positive, 3 negative are connected, and then they are connecting in this terminal, and from here 1 positive and 1 negative has been taken out. So this is an input and this is an output. This is how you have to understand this. Similarly, here if you see, here instead of, if they have connected, this is the input, then output has to be taken from here. If this is the input, then output has to be taken from here. But here they have connected this and this, so there is no output has been properly connected, and that's why this data will not come. Okay, so you should not do like this, because here we see that two cable has been taken, but these two are, instead of connecting together, they have connected separately. If you provide input here, then your output should come from here. If you provide input here, then output come from here. Here there is no cable. So this meter, if it is a, for example, if this is a EB meter wire, then EB meter data will not come into the Everest or Zabbix, because here cable is not connected. So what we have to do, like this is a EB meter and this is a DG meter, all these positive and all this negative, they have to short together, and then they have to either connected in this PCB, this terminal or this terminal, and accordingly you have to take output either from here or from here. So this is the basic difference which we need to understand. Similarly, if you open a SMPS, Vertiv SMPS 48 kilowatt, on the right hand side these are the terminal given, where you can see this is a 34 and 33. This two terminal is there, where the final output from the LT panel will be terminated here. So if this is connected here, then your data will directly read by controller, and from controller it will go to DCN router. If DCN router is live, we can see the data into the Zabbix. In the guideline, this picture has been given, this 33 and 34. So I am just giving the correct picture of the equipment, so you can read the guideline very clearly. I will take you to the guideline also, and I will in the mail also have attached the guideline. So that guideline you have to open it, and parallelly if you see this tutorial, then you can easily match the things, and you can, only a technician can easily configure and correct the wiring, and site can be made visible. Now third one is the DG controller. So DG controller also, if you see, this is the 49 and 50, 49 and 51, positive and negative. 51 is positive, 49 is negative. These two wire you have to connect here, and this will directly go to the LT panel. So DG controller positive negative will go to the LT panel. Then in LT panel there is a EB meter and there is a DG meter. Both have a positive and negative. 3 positive, 3 negative, both will be combined together, and then it will be connected to the PCB, and from PCB it will go to the SMPS. So now let us understand, this is a drawing which has been given in the guideline. So now you understood that how many PCBs are there, how many meters are there, how we have to connect. So now things is pretty clear, and now once you read this drawing, it will be very easy to interpret and visualize. Like DG1 controller, which is a GCU, like which is installed outside the server hall. This is a LT panel section, SAB incomer and DG1 incomer. So this is a Satec meter of ACB, Satec meter of DG1. So as we discussed that there is a positive and negative. So first of all, what will happen? One cable will come from the DG, okay, and that the DG controller cable will come from the DG, and it will go to the ACB incomer. So this positive and this positive will be common, this negative and this negative is common, this ground and this ground is common. Now from here, this two positive, one positive from the DG controller and another positive from the SCB, all these two together, it will go to the next meter, which is a DG meter. Here it will be terminated positive, and this negative, common negative, will be terminated at the negative. Again from here we will take a one positive, one negative as a parallel, and we will connect to the PCB. This is the one PCB. Another two PCB we will not touch it. We will connect this as an input. This side by side is an input, and this opposite are the output. So if we have taken this input, then we have to use this output. If you connect input here and use output this, it will not work. So we have to connect input here, and we have to use this as output. So here this positive has been given, negative has been given, earth has been connected. Then from here we have to use one positive, one negative, and this will go to the SMPS. And in the SMPS, as I show here, it should go to 33 and 34. If you see in the picture, it will come here. So here you have to connect. Like this cable has been connected in 31, 32. Similarly, we have to connect in 33 and 34. So that's how we need to complete this. So if this way this wiring has been completed, then next is the parameter setting. This wiring is applicable for a single DG and single SMPS. Okay. Now if you have a double DG, in that case one PCB you have used for the DG1 EB meter and DG1 controller. So for the DG2 you need to connect DG2 LT meter and DG2 GCU. These only two you have to connect, because EB meter is already connected here and there is only single EB. So EB meter is already connected in the PCB1. So for the double DG case, only second DG LT meter, okay, which is here we see in this drawing, like this is a second DG, this LT meter, okay, and second DG GCU. This we have to connect together to the PCB2. So one PCB we have used for DG1 and EB. Second PCB we will only use if we have a second DG installed. If second DG is not there, we don't need to connect PCB2 and PCB3. Both will be in a spare condition. If second DG is installed, in that case second DG will be connected to the PCB2. Okay. So now let us understand the second DG scenario. This is a scenario for the double DG case. So here EB section is not considered because EB is not there. EB is already using PCB1. Now this PCB1 has to be considered PCB2. There are three PCBs. One is already used. Second we will be using for the second DG. Okay. So now similarly same DG controller, say that wiring will come from 49 to 51. This will go to, from here it will go to straight to DG meter, and from DG meter it will go to PCB2 input, and from PCB2 input this output will be directly connected to the SMPS. But now there is a second SMPS. If there is only one SMPS is there, okay, in that case this cannot be connected there. But for the double DG, there is a DG interface box is been given. There this connection has to be terminated. It should not go into the SMPS. So this DG interface box, if it is provided, we can connect the output PCB terminal to this. Otherwise we will leave like that. So in nutshell, we will only able to see the parameters of EB DG1. That's the only parameters is visible, which is a master DG. If second DG is there, this parameter can be visible if there is a interface box has been provided with the SMPS. Okay, if this box is not provided with the SMPS, this parameter is not visible in the Zabbix. This is applicable only for the non-RTU side. If there is a RTU is provided, then all DG can be connected, then that is not an issue. But if it is a non-RTU case, in that case master DG data and EB data is visible. So I think this is now clear. Now next one is a parameter settings. So there are three different devices which we need to integrate. One is the GCU, which we can call as a DEF controller. Mainly we are using a Supernova DG, so I have mentioned DEF controller. If we are using Mahindra DG, then there is a Satec is also there, or Deep Sea is also there. So based on whatever controller they have used, we have to see their parameters. Then second one is the LT panel meter, which is a Satec make meter, and third one is a SMPS controller. So all these three different devices has their different parameters values. This we have to go into their settings and we have to make it correct. Even if we have made the correct wiring, but if this parameter is not properly set or configured, then also we will not have a data available in Zabbix. So first you have to complete the wiring part, second the parameter setting part. This two has to be carefully completed. Now all new AG2 sites we are using only Vertu or Emerson make 48 kilowatt SMPS. Recommended software is 3.55. and AEM card version should be 4.04. Even if your software version is 3.54, still data can be visible. But minimum 3.54 has to be there. If 3.55 is there, it is very good. Even if 3.54 is there, it is still okay. But it should not be lesser than 3.54. Otherwise, your data will not come. So if 3.54 or 55 is not there, please raise a PE and get this software upgraded through NHQ engineering team. They will remotely upgrade this software. Okay, so you have to fix a date, raise a PE and get the correct software updated in the SMPS controller. First of all, that's the first part. Now second one, once your parameter and once your software part is okay, then basic setting values we have to check inside the SMPS controller, then in the Satec meter, and then in the DG controller. All three things we have to go and we have to set it correctly, and after that one by one data will start coming into the Zabbix. So now what will we do? We will opening the guideline which has been released by the engineering team. In that guideline we will only look for the setting part, because wiring and other things we have already discussed. So I will just take you through the page one by one, and mainly we will discuss on the parameter settings. 20 ohm resistor at the extreme end of the RS485 network, like DG controller and between RS485, if this cable length exceeds more than 50 meter. Like for example, I can just here, like this is your DG controller and this is your LT panel. Now if this distance between the DG controller and LT panel is more than 50 meter, then the extreme end you have to use a 125 ohm resistor. So 125 ohm resistor, like this is your positive and this is your negative. Here you have to use 120 ohm in a parallel. So I will just show you that supernova controller here. If this distance between the DG controller and LT panel is more than 50 meter, then what we can do, we can use this 49 and 51, which is my positive and negative. In that parallel I can loop 120 ohm resistor. So that's because your data will not drop, and correct data should come into the Zabbix. That's the only reason that this we have to do it. Okay, this is a PCB part also we have discussed. This is a back view of the Satec energy meter. This is RS485 connection terminal. This also we have discussed. This is a DG side also we have discussed. And then now that's a basic integration activity and what we have to do. So quickly we will see that this RS485 cabling we have to see. Then software version, as I mentioned, it should be minimum 3.55 or 3.54. 55 is very good. 3.54 also data is coming, so also that will work. And once you upgrade your software, then your in a SMPS controller 530B, port B baud rate should be 9600, and there is a setting called external ACEM. That setting has to be, you have to select the Satec. Okay, this is what you have to do. And once you open a Satec meter, in that EB meter has been slave ID is 20, and for the DG it is 21. This is common for old AG2 and new AG2. Okay, old AG2 we are using Vega meter. There also the slave ID for EB meter and DG meter is like this: 20 for SEB meter and 21 for DG meter. And baud rate also we have to select 9600. Similarly in DG controller also we have to select the baud rate, which is 9600. So baud rate has to be same in the DG controller as well as in the Satec meter as well as in the SMPS controller. So point number 4 is for the SMPS controller, point number 5 is for the LT Satec meter, and point number 6 is for the DG controller. So now here brief thing has been given, then we will discuss in detail that how to reach to that parameter, and then how we can configure that. Before software upgradation, this should be the value. Like you go into the main menu in the SMPS, then settings, then communication settings, then port B, and set value to slave, then main menu, settings, communication setting, AEM version, set value to enable, and then port B baud rate 19200. But once you upgrade the software, you have to select this external ACEM, you have to select Satec, and port B baud rate you have to modify to 9600. Earlier it could be 19200, but now you have to modify to 9600. So this is very important thing in the SMPS controller. Okay, once this has been done, then only it will start reading the value from the LT panel as well as from the DG controller. So this is a picture of the SMPS controller. Like port B is a slave, and this is a AEM card. External AEM we have to select Satec. AEM also you have to make enable. Okay, then in a system setting you have to go in a GCU. In GCU also you have to enable. So once you enable the GCU, it will start reading the DG data also. So now SMPS part is over. Now we will go into the Satec meter. Satec meter also, this is a front panel. Here there is a select button and up and down scroll button. So here it clearly mentioned that we have to press the button 3 times, select button. Then you will see that there is a CHG row, third row CHG will be displaying. It will be flashing, and then you have to press the enter once. Then the first row RST will be there. Okay, then you will see that PRT1 will come in the first row. Then you have to select this up and down arrow 3 times, what they have mentioned here. So basically if you follow these steps for the Satec meter, okay, then it will come 485 here. Then you have to select your device address also, device 20 for EB and 21 for the DG. So when you do the configuration for the EB meter, you have to select the device address 20, and for the DG1 you have to do the 21. Okay, then baud rate also you have to select 9600. To select this you have to follow these steps. These steps is very important. It is giving you the step-by-step guideline that when it will be flashing, how to enter the value, how to save, how to escape. All this has been mentioned very clearly. So this you have to select. Okay, and once you are done, then you have to press the escape button 3 times. Once you do this, then your meter will come out from the programming mode, and then all the parameters what we have modified will be stored in the meter. So this is the Satec meter configuration part is completed. Now we will go to the GCU, which is a def controller in our case. Here we will press the OK button. Once you press a OK, you will get this display. In this you have to select this arrow. Once you select by scrolling up and down, you have to select this and then press the OK button. Then it will go into the configuration mode. Okay, then you will see there is a 7500 communication tab is there, which you have to select by this scrolling up and down. After selection you press OK, and then you will see there is a 7510 will come, and it is mentioned external communication ID. Again you select this and press OK, and then there is a address menu will come, and there you have to it should be 9, and then you have to click OK. Okay, and then second, enter the password, which password could be 2000 or 2002. If this password is not known, you can call the Supernova team and you can take the password for this configuration and you can correct it. So device address, you have to select 9 by using up and down. If it is already 9, that is okay. If it is not 9, you have to select 9, and then once it has been selected 9, then you can just click on this arrow which will take you out from this controller setting menu. You will exit from this and your parameter has been done. So we have learned this, how to connect the Satec meter, how to configure Satec meter, then how to configure DG controller, how to configure SMPS controller. Once you do this, then I think you will see that once it has been done, then initially this data was not here. If you see that it is a 00 kilowatt in the DG and 00 kWh, even EB also 00 kW and 00 kWh. After doing this, you can see here that now you are getting DG fuel level, DG run hours and DG kWh, and also EB kilowatt and EB kWh also. So this exercise will start, you will complete successfully, then in the Zabbix you will start getting this value. So at least energy monitoring will be started. After this, we will monitor your daily consumption of EB and DG and SMPS and everything, and then we will calculate that what is our PUE and what is our diesel consumption, etc. And after that, if you will come to know that now data is visible but accuracy is not okay, then we will provide you further details in the Satec meter that you have to verify the CT and PT ratio also. But mostly this is all factory set value, because meter and LT panel both has been supplied by the L&T. So they must have done this by default from their side. So once it has been okay, then I think correct visibility will be there and we can monitor the data correctly. So that's what all about this training, and I hope that now you understood this and you have to circulate this video. I am providing you the YouTube link. This YouTube link you have to provide to your SP supervisor and SP technician, infra engineer, infra lead, and they have to follow this guideline. Parallelly, the PDF copy of the guideline also you have to circulate to them, so they can refer the page by page and they can execute this at the site. And in between, if they have stuck, they can use this video also. Okay, so that's the overall objective of this video, and I look forward that you connect all these sites immediately, because we have 82 sites as on today. Today is 30th September, and we have 80 sites new AG2 where this connection is not been done correctly. Okay, so before this number goes high and it becomes a huge project for us, let us start segregating, and let us distribute this work to all infra lead and infra engineers and SP technicians, and let us support them by providing the proper guideline, so they can go to the site and they can complete this pendency in a very shortest time. So I look forward to your support to complete this project, and let us make our all sites visible in the Zabbix. Thank you.